Hello everyone, this is second part of the lesson Gravitation, class 10th of Science 1. Okay, so we completed till the topic Earth's gravitational force. Now in this video we will start from Earth's gravitational acceleration, which is denoted by small g. Okay, now what is it? We know that the Earth exerts gravitational force. Okay, in last video we already discussed about the gravitational force, and we have seen that how it affects the object near it. So Earth exerts gravitational force on the object near it, and according to the second law of motion, what is the law? Force acting on a body results in its acceleration. Okay, so the equation of this law will be force is directly proportional to acceleration. That means we can write here force is equals to mass into acceleration. Now here we will replace acceleration by g, small g. Okay, so our new equation becomes F is equals to mg, where F is force, mass, and this is gravity. Now thus the gravitational force due to Earth results in its acceleration. That means as a gravitational force will act on a due to the gravitational force, Earth results in its acceleration. Okay, so this is called as a acceleration due to gravity, and this is denoted by a g. And this is a student, this is vector quantity. Vector means it will depend on magnitude as well as direction. Okay, so this is denoted by g, small g, and the direction of acceleration due to gravity, it's directed towards the center of the Earth. Okay, it is directed towards the center of the Earth. It means it is directed vertically in downward direction. Now let us derive the value of g. So the value of g on the Earth's surface. Okay, value of g on the surface of the Earth. So we know that this is acceleration. Now this is the gravitational force by Newton. So force is equals to gmm upon r square, where m is the capital M is the mass of the Earth and small m is the mass of an other object. Now according to the second law of motion, Newton's second law of motion, we seen that force is equals to mass into g, mg. Now from these two equations, we have these two equations. First is about the gravitational force and second is the acceleration, gravity. Okay, so F is equals to mg. Now from these two equations we can get mg. Okay, we can write here mg is equals to, we are equating these two equations, gmm upon r square. Alright, now here we can cancel m and m. So we will get g, small g is equals to gmm upon r square. So student, this is a value of a g which depends on which depends on this constant. Sorry, here g is the constant mass of the Earth, and it is a distance, square of the distance. Okay, so the value of g on the surface of the Earth. Now when we will put the value of g, which is constant, gravitational constant, mass of the Earth, and here this is radius of the Earth. Okay, so radius of the Earth we can write as capital R square. Okay, so when we will put all this value, which will be, now I am putting the value of all the terms. We have g as 6.67 into 10 raised to minus 11 into mass of the Earth is, mass of the Earth value is 6 into 10 raised to 24 divided by radius of the Earth will be 6.4 into 10 raised to 6. Now this is a square, so we will do this is square. Okay, so student, after calculating all this term, we will get the value of g as 9.77 meter per second square, which is approximately equal to 9.8 meter per second square. Okay, so this is a acceleration due to gravity value on the surface of the Earth, which is 9.8 meter per second square. Okay students, so this value of g, it is depend on mass and radius of the Earth. Okay, now let's see next topic. Now we are going to see, student, the variation in value of g. Okay, that means how the value of g changes from place to place on different surfaces. Okay, now next topic is variation in value of g Okay, now this variation in value of G we are going to see according to the formula of G, which is just now we have derived this, which is small g is equals to gm upon r square, where m is the mass of the earth, r is the radius of the earth. Okay, so as the value of G, which is acceleration due to gravity, is directly proportional to the mass. Okay, so this is directly proportional to mass and it is inversely proportional to the square of the distance. Directly proportional to mass and inversely proportional to the square of the distance. So it means as mass increases, okay, mass increases, acceleration due to gravity also increases, because these two factors are directly proportional to each other. And if the distance goes on decreasing, okay, sorry, if the distance goes on increasing, so if we will increase the distance, so these two factors are inversely proportional to each other. So if we will increase one factor, which is radius, so the value of G, acceleration due to gravity, will goes on decreasing. Okay, now just see how the value of G changes on the different surfaces. Okay, so change along the surface of the earth. Okay, so student, the value of G, okay, value of G on the surface of the earth, we have seen that it is 9.8 meter per second. Okay, so this value is G is for on the surface of the earth. Okay, now as we will move away from the surface, higher from the earth surface, so this value is decreases. Okay, because distance and G is inversely proportional to each other. Now we are going to see the value of G and different surfaces, like at pole and at the equator. Okay, now the surface, okay, the earth surface, it is spherical in shape. So equator, distance from the center of the earth and equator, this is larger as compared to the center, from the distance between the center of the earth and pole. So this is a larger distance and this is a smaller distance. Okay, these two are the poles, north and south poles. Okay, now the shape of the earth is such that it is flattened. Okay, it is flattened at the pole. So this, it's flattened at the pole and it is bulges. Okay, it is bulges at the equator. You can see here it is bulges at the equator and it is flattened at the pole. Therefore the value of G varies from place to place. So it is different for equator and it is different for the poles. The distance between the center of the earth and its pole is less distance, okay, as compared to the distance between the center and the equator. This is less and this is a larger distance. Okay, all right. Now according to the formula of the gravity, acceleration due to gravity, this is a formula. So since the distance between the center of the earth and its pole is less than the rest of the earth, and hence value of G will be greater at the pole. So lesser the different distance, greater the value of G. Okay, because these are inversely proportional. And similarly, the distance between the center of the earth and equator is more. All right, more distance between center of the earth and equator. Hence, so as the distance is larger, the value of G at the equator is less. Okay, so less distance, G will be greater at poles. Okay, and at from center and equator, larger distance is there, so value of G will be lesser over there. All right. Okay, now next is change in value of G, acceleration due to gravity with the height. That means we are moving away from the surface of the earth, and the value of G, how it changes, just see. So here this is earth surface, center of the earth, all right, and this is a distance. So h is a certain height above the earth surface. This is earth surface, all right. This second sphere is the earth surface, and h is a certain height above from the earth's surface. So this is the earth surface, and above the surface of the earth at certain height we have h, all right. And d, what is d? This is a certain depth below the earth surface. So this is above the earth surface and this is below the earth surface. And c is the center of the earth. All right, this is the center of the earth. Now how it changes? As we go above the surface of the earth, above the surface of the earth, okay, the distance of the body, the distance of above from the surface of the earth, the distance of the body from the earth surface goes on increasing, and thus the value of g goes on decreasing. So distance increases, value of g decreases. All right, okay. And now we will see change in value of g with the depth. That means in here inside the earth surface, okay, certain depth below the earth surface. So how it changes at depth? As we travel inside the earth, okay, inside the earth, mass of the earth goes on decreasing. All right, and as per the formula, g is equals to gm upon r square, as g is directly proportional to m, therefore mass decreasing. Okay, depth at the depth of this earth, okay, so as mass decreasing, value of g also decreases over that. So these are the three places where the value of g changes. Okay, now next topic is mass and weight. Now what are these? Okay, first let's going to see mass. So mass, what is the mass? It is the amount of matter, okay, it is the amount of matter present in the object. Okay, that means this amount of matter present in the object, it is nothing but a mass, and mass is a scalar quantity. That means it is only a magnitude, not a direction. The quantity which is having magnitude as well as direction, that is a vector, but here it has only amount of matter, so this is a scalar quantity only, it has a magnitude, and the SI unit of mass is kg, that is kilogram. All right, and mass of value of mass is same everywhere and doesn't change even if we go to another planet. So this is same. All right, so for suppose we have one object whose mass is 10 kg, so this is same on another planet also. So if you will change the place, the mass of that particular object will be 10 kg only. Okay, so it is same, it doesn't going to change. According to the Newton's first law of motion, the measure of inertia of an object depends on its mass, that is higher the mass, higher the inertia. That means if the object is heavier, it has a higher mass, the inertia will be higher. What is the inertia? It is the ability of an object to resist change in its state, that is motion and rest. Okay, so this is a inertia. So this was all about mass. Now let's see what is the weight. All right, now weight, the force. This is a force with which the earth attracts the object is called the weight of an object. Okay, that means how this is weight is nothing but a force with which earth attracts the object. It is called as a weight of a particular object. That means how much amount of force is acting on an object, okay, with which the earth will attract that object. This is called as a weight. And the force F acting on an object, force F is acting on an object of mass m. Okay, that means F amount of force which is acting on an object whose mass is m on the earth's surface can be as weight is equals to force, which is equals to mg. That means mass into acceleration due to gravity. Okay, since weight is a force, so the unit of weight is also same as the force, which is Newton, and weight is a vector quantity. That means it has magnitude as well as direction. All right, now weight of an object changes from place to place as the value of g is not same everywhere. Okay, that means on the surface of the earth it is different, as we are moving away from the earth surface it is different, because value of g on the surface of the earth is 9.8, and as we are moving to the depth and away from height at a certain height above from the surface of the earth, so this is changes. Okay, so that means on different planet the weight of an object will be different. Okay, so this is a basic difference between weight and the mass. That means mass is same everywhere, and weight is different on different places or different planets. Okay, now our next topic, student, is a free fall. What is free fall? All right, now let's discuss this. Whenever an object moves under the influence of a force of gravity alone, it is said to be falling freely. That means only one force, gravitational force, that is only gravitational force will be acting on the body. Okay, or an object will fall only the influence of a gravitational force. It is called as a dead fall. That falling of an object, it is called as a falling. That means object is falling freely under the influence of a gravity alone. Okay, now during free fall, okay, that means when the object falls under the influence of the gravity only. So during this fall or during free fall, the frictional force due to air opposes, okay, the frictional force. That means air has a frictional force which opposes the motion of an object, and the buoyant force also acts on the object. Buoyant force, these two forces, like the okay, frictional force and buoyant force, these two different forces opposes the motion of an object, and thus, okay, that means they will oppose the object, motion of an object which is falling only the under influence of the gravity. But it is not possible when two different forces are there, like frictional force is there, buoyant forces is there. So the in that case, frictional force, free fall is not possible. Therefore the free fall is only possible in vacuum, because these two forces are opposing the motion of an object. Okay, thus free fall is only possible in a vacuum. And in free fall, the initial velocity, which is u of the object is 0. It means initially it is at 0 velocity, and it will goes increasing due to the acceleration due to gravity of the earth. Okay, so initial value of u is 0, but final velocity, or we can say its velocity will increases when due to the acceleration due to gravity of the earth. That means earth will try to pull itself with a greater extent, therefore its acceleration due to gravity of the earth. So the velocity will be increases over there. Right. Okay. Right, now velocity of a freely falling object can be calculated by Newton's equation of a motion. So these are the three Newton's equation of a motion, where v is equals to u plus at, acceleration, time, final velocity, initial velocity, final velocity, s is displacement, and okay, all right. So these are the three equations. First is v is equals to u plus at, s is equals to ut plus half et square. Third, v square is equals to u square plus 2as. Okay, now we will derive this equation. Okay, we will study these three equation of a motion under the two cases. Now first case is object falling freely from a certain height. Okay, that means object is at certain height and it is falling freely, so its initial velocity will be 0, and a, okay, this a will be is equals to g, acceleration due to gravity. All right, now hence the equation changes. These three equation are changes by this value. Now we will put u is equals to 0. So after putting u is equals to 0, we will get v is equals to 0 plus a will be replaced by g. So here v will be gt. So first equation will changes like this. When the value of u is equals to 0, a is equals to g. Now this equation become s is equals to half a will be gt square, plus this will be 0 into 2, which will be 0. Now s is equals to, that means displacement is equals to half gt square. Okay, now third equation will be v square is equals to u square plus 2s. Now this will be v square is equals to 0 plus 2gs. So v square is equals to 2gs. So these three are the changes equation of a when the value will be this. Initial value will be 0 and a is equals to g. Now we have second case also, where object thrown upward. Okay, so in first cases object is falling downwards towards the surface of the earth. Okay, now in second case object is thrown, here is the object, okay, and it is thrown in upward direction. So in this case, okay, now in this case this final velocity will be 0. Okay, we are providing an initial velocity and final velocity will be here 0. So v is equals to, we will put 0 and a is equals to minus g. Why this is minus g? So student, remember this thing, when object is opposing the gravity, okay, when object is throwing in upward direction, so it will always oppose the gravity, okay. So here value of g will be negative value of g. And in first case we have seen this is for falling towards the earth, so here a will be, in this case g will be positive value, okay. Now just put these two value in Newton's 3 equation of a motion. So first equation is v is equals to u plus at. Now let's put these two terms. 0 is equals to u. Now here in this case this will be minus gt because a is minus g, okay. So this will be, in this case, u is equals to gt. Now second equation will be s is equals to half at square plus ut. Now in this case we will get s is equals to, this a will be replaced by minus g, which will become half gt square plus ut, okay. Now third equation is v square is equals to u square plus 2as, okay. Now v is equals to 0 is equals to u square minus 2gs. That means u square is equals to 2gs. These are the three equations of a motion when the case is object thrown in upward direction. Right. Next topic is gravitational potential energy. Now students, we know potential energy. What is this? Potential energy is the energy stored in an object because of its position or state. So this is potential energy, okay. Now potential energy increases in height from the earth's surface, okay. Increases from the height of the earth's increases with potential energy increases with increase in height from the earth's surface. It means height increases, potential energy will increases, and potential energy is 0 on the ground. Now first of all, formula of potential energy is mgh, okay. So at the ground, okay, where initial velocity height is 0, okay, and at the ground here h is equals to 0, so potential energy is also 0. On the ground it is 0, but this formula is only applicable for the height which is small compared to radius of the earth. All right, so for the smaller distance this we can use this formula, but for larger heights, okay, larger height, that means from a radius of the earth, if the height will be larger, that means, for suppose this is earth, okay, and this is a radius of the earth, this is r. But if we are having an object from the earth surface at a particular height of the earth surface, so this will be height h, and what will be the total height, student? It will be r plus h, okay. So this is for the larger distance, okay. So in this situation the potential energy formula will become, we can use potential energy is equals to minus g mm upon r plus h, where this factor is the total height, where m is the mass, r is the radius of the earth, okay. So this is the gravitational potential energy. Now last topic of this lesson is the escape velocity. So this is the minimum velocity, okay. This is the minimum velocity required by a body to overcome the gravitational pull of the earth is called as the escape velocity. Right, when body is thrown in upward, its velocity goes on increasing, right. When body is thrown in upward direction, so what happened? Its velocity goes on decreasing and it becomes 0.Its velocity will be 0. It becomes 0 at particular height, and after that it start falling downward. That means here it has a maximum velocity, okay. Now as we have we will provide the maximum initial velocity, okay, and it will the object is thrown in upward direction, so its velocity will be decreases, and after reaching at a particular height its velocity will be equals to 0, and after reaching at this point the body again it will start falling in downward direction just because of gravitational force, okay. So the minimum height that an object can reach before falling downwards depend on its initial velocity, that means if we will provide a maximum amount of initial velocity, we should increase the initial velocity of the object. It will reach larger and larger height, and it will be at rest position over there. Now just see the formula here. For an object of mass m, okay, that means we have an object of a mass m, and on the surface of the earth, here we have two energies, kinetic, total energies we have to calculate, okay, kinetic energy, potential energy. Now here we have kinetic energy, which is half mv square, and potential energy, this what is this? Potential energy will be here, minus, on the surface of the earth, minus gmm upon r. Okay, now total energy, which is E1, this will be sum of these two energies, kinetic plus potential. Okay, now here kinetic energy is half mv square, just we are putting the values here, plus minus gmm upon r. Now just solve this first, student. E1 is equals to half mv square minus gmm upon r. Okay, minus gmm upon r. On the surface of the earth, that is why we are having only r. We are not having on the r plus l, because our object is at on the surface of the earth. Okay, so this will be only r. Now here kinetic energy, in second case we have at infinite distance. Our object is at infinite distance from the earth's surface. So in this case kinetic energy will be 0. Alright, half mv square upon 0, because here v will be 0. And potential energy will be minus gmm upon here r. What will be r? Our object is at infinite distance, so value of r will be infinite, and it will become, potential energy will be 0. So in this case E2, kinetic plus potential energy will be 0. Alright, now the total energy, alright, from the principle of conservation of energy. What is this? From the principle of conservation of energy, energy cannot neither be created nor be destroyed. Just one form of energy is converting into the another form, so it will be E1. Now here we will have E1 is equals to E2. Alright, so value of E1, what is E1? This is the value of EM. Okay, now here according to the law of conservation of energy, E1 is equals to E2. Now let's substitute value of E1. So E1 is half mv square minus gmm, half mv square minus gmm upon r. Okay, and E2 we have is 0. At infinite distance it will be 0. Now let's rearrange this. Half mv square is equals to gmm upon, it will be gmm upon r. Okay, now let's cancel these two terms. We will get half v square is equals to gm upon r. Now student, here we have to calculate escape velocity. Okay, so instead of writing only v, we will write v escape. Okay, v escape, which is square, is equals to, now this 2 will comes at this side. So this will be 2 gm upon r. Now this here square is there, so we will take square root. Taking square root, we will get v escape is equals to square root of 2 gm upon r. Okay, now student, just look at here. We have value of g. What is value of g? Acceleration due to gravity. G is equals to gm upon r square. Okay, but and here we have only gm upon r. Now we will multiply this. We will multiply and divide. This is equation 1. Multiply and divide equation 1 by r, so that we can get here r square, and instead of this term gm upon r square, we can substitute here g. Okay, that means we escape velocity in terms of g. So here it will be v escape is equals to, after multiply and divide by, okay, r, multiply by r and divide by r. Okay, now after doing this, we can write here 2 gm into r divided by r square. All right. Now this term gm upon r square, this is what? Acceleration due to gravity value. Just substitute this. So this becomes 2 small g r. So this is the value of escape velocity square root, which is equals to square root of 2 gr. And when we will substitute the value of this g and radius of the earth, okay, acceleration due to gravity and radius of the earth, we can calculate the value, exact value of escape velocity, which will be b escape is equals to square root of 2. So value of g will be 9.8, okay, 9.8 meter per second, and meter per second square, and radius of the earth is 6.4 into 10 raised to 6. So student, after calculating this whole term, multiplying and doing square root, we will get the escape velocity value as 11.2 kilometer per second. Okay, so student, this is, here we have completed gravitation with 2 part. Complete lesson here we have to complete it. Okay, so I hope you all have understood. Thank you.